Hi class, this is really weird. Anyway, hope you're enjoying your snow day. I didn't want to get behind, so I decided to go ahead and attempt to make a video, so I hope this turns out. But we're going to go ahead and start Chapter 8, Transformations. The whole chapter is called Transformations, but this particular lesson is called Reflections. So I'm going to do I don't have one of those remote things, I have to go over here and change the slide. Oh, of course I don't know how to do it. Oh, there we go. Something is wrong with this picture. Can you tell what? I'm going to give you a few minutes to think about it. See if you can figure out what's wrong with this picture. You can stop the thing and come back to it. Well, it was upside down. This is the right way, right side up. So the edge of the lake here, it divides the picture into two parts, the upper part and the lower part. The two parts in which the points above the edge have it, and it divides it into two parts that have the points above the edge and the image points below. So this is actually a T that I made in a little dot at the top of that tree. If you go down, there's a little T with a little 1. And this corresponds to this point. Here I have, boy, even I can't tell what it says. I wonder if I can make that clearer. I just can't see when it's farther away. Anyway, whatever I call that, it doesn't really matter. Where the white goes up and then the tree starts, I put a dot there, and this dot corresponds to that one. And then, so like if it were I think it's an S. S, this would be S with a little 1 below it. Oh, actually, here's a pen, like S, and then the other one would be S1. And this is T. And then this one here is T1. This one here I called R, and this one here is R1. So you can see that they have the little corresponding parts. And I'm going to go ahead and erase this now. I'll leave that there in case I need it again. I'm going to try to get it up a little closer so I don't have to keep walking in front of it. Hopefully, yeah, that's a lot better. No, either way I gotta walk in front of it, so I'm gonna go back, make it at least a little bit bigger. All right. So if we draw a line from a point to its corresponding point, in all of these cases, the reflection line, this is the reflection line. The reflection line is the perpendicular bisector of all of these segments between the points. You can see that they are right angles, perpendicular bisectors. And there are some points on here also that I forgot to actually label, but I made them black so you could see that they are actually on the line. So we're going to start with the definition of what a reflection is. So the reflection of a point, let's say P, through a line L is the point itself if P is on the line. So like in those, when the black dots were on the line, the reflection point would be P. But if it's not on a line, it's the point 1 such that L, the line, is the perpendicular bisector of the P1. So what that means is P would be like here. The line, the reflection line would be here, and P1 would be here. So they're saying such that L, this is the L is the perpendicular bisector of P, oh, that should have a line over it. I just couldn't do it on my program that I had. So if P1, line P1, if P is not on the line. So that's the definition of the reflection of a point. So if it's on the line, the reflection is, P1. Okay. All right, transformation theorem 1. If you have a pair of points, so here I have one here and one here, and then there are corresponding points here, right? The reflection of a pair of points through a line preserves distance. So here's the line, and the reflection, this is the reflection here, this is the original, the reflection of a pair of points that goes through a line, so from here to there, crossing over the line, it preserves distance. So from this point to this point is going to be the same as from this point to this point. And that's what it means by preserves the distance. So there are two ways to find the reflection of a point. One is to use a mirror, and that is one of these things. And what you could do is, it wouldn't work here, but if you had, say, a point here, you could put it here. I wonder if it would work like this. And I can actually see through that point, and I can tell, like, if the line is right here, except I moved it. I can actually see the reflection point is over here, and I can draw it, and you can see that they're the same distance, and then you would just connect them. That would be the perpendicular bisector, that would be the reflection, and this would be the original. But if you don't have one of these, a mirror, you can draw a construction. And so that's what we're going to do. So that's how to locate the reflection of a point through a line using a straight edge, which is our ruler, which I need to go over there and get, and a compass. And you're going to have a worksheet 801 that I have messaged you, and it's going to have it on there on how to use that. Sorry, I have to keep walking in front of this. So this is your worksheet. We're going to be doing this one right here. We're going to find the reflection point of X and O. So the first thing you're going to do is put your compass, and I have to kind of pretend. So this is going to be my pointy end where that pencil is, and this is going to be what would be my pencil end of the compass. So you're going to put your pointy end on the point of 0, and then you're just going to make an arc, and I'm just going to pretend you would make an arc like that while this is here and that comes out, and you make an arc. So where you have 2 points. Then, not moving your compass, keeping the same distance, you're going to put your point on this line and make a point here. And then you're going to put it on this one and make a point there. And wherever they cross together, that's the perpendicular, that's the point right here. And then you would, connect those two. And that's how you would find the reflection. Actually, you wouldn't even need to do the line because we're just finding the reflection right now. So that would be the reflection, the point right there. And then you would do the same thing with X. So we're going to leave that like that. And you would, again, the black one didn't work so well, so I'm going to use this one. You put the point on X, the point of your compass, and then you would make an arc. So it'd be kind of like something like that. And then from those points, you would put the point where you where the 2 lines intersect. make an arc up here, and then the same thing over there, and you'll make an X somewhere like that. And that is the point of reflection right here. So that's how you find the reflection point of a point. And I actually wrote out the words. So pretty much what I just said. You put the sharp part of the compass on the O, you draw an arc that intersects line L in 2 different points. Then with each of those 2 intersection points as the center, then we put the sharp part of our compass there. We draw 2 more arcs with the same radius as the first, and the point where they intersect is the reflection of 0. So now we're going to do this one here. A is the midpoint of NAG. Of NG, so therefore we have NAG. So what you need to do is you need to fold your paper in half, so that, or use a mirror if you have one. It's a plexiglass, so if you have a piece of plexiglass, that might work. Or you use a mirror to find the reflection points of NAG. So what we did here, you're going to do the same thing here. So you're going to, over here, you're going to end up with, I'm saying N1, but it really should look like this. N, and then a little 1. But my program would let me do the little, whatever that's called, underscript or something like that. So I'm just doing N1, but it really should be N with a little 1 below it. So you're going to find the reflection points of N, and so N1 would be over here. And then you're going to find the reflection point of A, which would be right there, and that would be A. And then right here you'd write A1 right next to it. Of course, that's really big because I'm using such a big pen. And then G, and then you're going to name them A1, and then G1. And remember, A1 looks like that, and G1 looks like that, right? So that's all they say to do for that. Then they want you to draw N1, G1. So you're going to draw a line from N1 to G1. And then how do NG and N1, G1 appear to compare in length? So I want you to think about that just for a minute. It won't take long. How do you think they compare in length? And hopefully you said they appear to be the same length. So hopefully, yes, you did say that. Then it asks, what relation does A1, that would be like right here, A1, appear to have to N1, G1? What relation does A1 appear to have with this line segment? Go ahead and think about that for a minute. And hopefully you said it appears to be its midpoint. Just like A was the midpoint of NG, A1 is the midpoint of N1, G1. So hopefully you said, hopefully that's what you said. So what relation does L, this is L, the line, appear to have to angle NA, N1 and angle G1, A1 and G? What relation does the line seem to have to these angles, this angle here and this angle here? Go ahead and think about that for just a minute. You can turn it off if you need to. And hopefully you said that it appears to bisect angle NAN and angle G1 should have been A1 or A. Hopefully, hopefully you did say that it does appear to bisect the angles. So now they want you to do the same thing with the C, W, and O with line, probably that's supposed to be line L. They want you to name the reflections C1, W1, and O1. And of course that's on that handout that you should have printed out that I asked you to print out. So so go ahead and well, I'll give you a few minutes to do it right now. Go ahead and start making the reflections of C1, W1, and O1, and then draw triangle COW and then triangle C1, O1. Remember, this is C1, C1, O1, and W1. Okay? I'm going to go back to the, while you're doing that on your papers, I'm going to go back to the handout. I don't know if it's on the next page. No. Oh, how did that happen? So you guys keep working on that while I'm trying to get to the page we were at. Here we go, COW. So they want you to find, and I'm going to go ahead and do it this way while you're doing it on yours. You don't have one of these, so you'll have to do it with your construction, if that'll work. Does it? Oh yeah, works a little bit, not fantastically. I think it's right there, and I think the W is right there. Yeah. Okay, so this is going to be C1, this is going to be W1, and O is still right there. So we're going to make a triangle, and then we're going to make a triangle out of this one. Go ahead and stop the machine. Oh, did I do that right? I think so. Oh yeah, that's W1, that's where I wrote. Okay, go ahead and stop the machine if you're not ready. When you finish, when you get to this point, you've made triangles out of them after you've made the reflection. Go ahead and start up the machine again. Okay, so what relation, gotta turn this, what relation does triangle COW appear to have to triangle C1O1 W1? Try to think what relation the two triangles have with one another. If you need to turn it off and come back and turn it on when you're done, go ahead and do that. I'm going to go on. So, did you say that they were congruent? Hopefully you did. And we're going to go on to the next problem. Oh, is that as far as I finished preparing? It is. So I guess that's where we're going to be done for now.